Hi, my name is Chris Woodward, and I'm a Developer Relations Engineer at ArongoDB. Thanks for joining us for the second course of our Graph and Beyond Lunch and Learn sessions, where we give you bite-sized bits of info about ArongoDB. Today, we're starting out with a new feature coming along with ArongoDB 3.9, Hybrid SmartGraphs. We'll start with taking a look at what exactly SmartGraphs are, what improvements come along with Hybrid SmartGraphs, and we'll take a look at an example of how to set up SmartGraphs with ArongoDB. To start out, what are SmartGraphs? Well, SmartGraphs are an enterprise feature that improves the ability to scale out your graphs in ArongoDB by optimizing how your data is sharded in a cluster. The goal of SmartGraphs is to keep your graph traversals fast while horizontally scaling large graphs. SmartGraphs allow for combining the knowledge of the queries being executed on the data, as well as the natural subgraphs that might exist within it, and using this knowledge to inform how to shard that data across your database servers. The result of this smart sharding is that your graph traversals can now be executed with near local database performance. If we take a look at an example of a standard graph distribution in a cluster, you can see that a graph traversal can potentially result in many network hops back and forth across multiple database servers. If we instead shard the data into natural clusters or subgraphs, this can substantially reduce the need for additional computation and network hops. So, how do smart graphs actually work? Smart graphs rely on a smart graph attribute to inform the database on how to shard the data. This smart graph attribute is unique to each dataset. You can choose it based on multiple factors, such as the common attribute found in documents that are frequently used as the start vertex in graph traversals, or perhaps an attribute that is most common within your data. The goal is to find a sensible way to organize your data across database servers, and this usually requires a little bit of planning before setting up your smart graph. Once you've decided on a smart graph attribute, the database server will now attempt to localize the vertices with other vertices that have the same smart graph attribute value, as well as the edges that connect them. This smart sharding results in reduced computation and a reduced number of network hops. Some considerations to think about when setting up a smart graph. When defining a smart graph, a few things to consider include being aware that all vertices must contain the smart graph attribute, with one exception that I'll point out in just a moment. It's good to be aware that smartified document key values are slightly different as well. The underscore key value is actually what lets the database know where to put each document. The first part of the key is actually the smart graph attribute, followed by a colon, and then a standard underscore key value. This is important to know since this may change how you perform underscore key lookups in your AQL queries. Finally, the smart graph attribute and the number of shards defined with your smart graph are immutable. So it is good to plan these out before setting up your smart graph. Smart graph edges have a small change to the underscore key value as well. Similar to the vertices and the smart graphs, the underscore key value informs the database server where the edge should live. So it contains the smart graph attribute with a standard underscore key value between them, as seen in the example to the right. There are a couple different smart graph types. Smart graphs can be set up in a few different ways to better fit your specific graph needs. We have been mostly looking at what we just call the standard smart graph. However, you can also define your smart graph as a disjoint smart graph, which prohibits edges between graph nodes with differing smart graph attribute values. This is not suitable for all graphs, but if possible, it offers the guarantee that the entire graph traversal happens on a single database server. And as of 3.9, you can now have hybrid and hybrid disjoint smart graphs. Hybrid smart graphs bring a powerful addition to smart graphs. Hybrid smart graphs allow for including satellite collections with your smart graphs. This is a natural evolution of the smart graphs, which focuses on trying to localize as much as the graph traversal as possible. Satellite collections don't require a smart graph attribute. This is that one exception I was talking about earlier. The smart graph attribute isn't necessary since the purpose of it is to inform how to distribute the data. However, with satellite collections, they are already distributed globally to every database server, so there's no need for additional sharding. Including satellite collections means that your graph traversal can now be even more localized, meaning even better performance. With hybrid smart graphs, one change that comes with them is, compared to standard smart graphs, is that the underscore key structure is a two-part structure rather than the three. This is a natural result of the satellite collection not needing to have a smart graph attribute. If you have edges with satellite vertices on each side, then the underscore key value will be the standard one-part underscore key value, since neither document is involved in the smart sharding. Now that we've taken a look at the concepts of smart graphs and the benefits that come along with using hybrid smart graphs, I wanted to show you an example of creating your own smart graph. I'll only briefly go over the contents of this notebook as it provides a little bit more detailed information of what we've already covered in this video, and it actually walks you through creating your own hybrid smart graph. This notebook downloads a small LDBC sample dataset and imports that dataset and creates the hybrid smart graph using an import script. This import script and dataset are all freely available on GitHub. The parts that I wanted to specifically point out were going to be how exactly we create a hybrid smart graph. When creating smart graphs, you use the smart graph module, and then you call the create function. The main difference is that with this create function, you can now pass through the satellites. These satellites is a list of satellite collections to be used in the smart graph. Once you have your smart graph created, you can start exploring it in the OrangoDB web interface. This is an example of the smart graph that is loaded once you go through the notebook. As you can see, these large nodes here represent people. These people are the smart graph attributes, or these people, I should say, contain the person ID that is used as a smart graph attribute. And you can see with all the relations connected to this person, why that was a good decision. The various nodes connected to the person include things such as the people they know, the interests they have, and the posts and comments they've created. Feel free to check this out a bit more on your own with the link provided in the description below. Thanks again for joining us for this Graph and Beyond Lunch and Learn session.